In this video, we'll start exploring the moving average, and in the next video, we'll look at the exponential smoothing. Okay, so before this video, you should already learn that the naive and the average of the historical value two method. As we noticed that both methods are very straightforward, and then even the first grader will, I think that for the naive, the first grader will be able to know, but for the average out historical data, that might need a little bit of statistical background before you can do it. But as you can see, both methods might not be able to capture every pattern we've seen from our previous pattern analysis, right? So therefore here we try to make it a little bit complicated. So first of all, we try to look at moving average. Okay, remember the analogy I mentioned before. Okay, you don't want to give a 2 years old, the 6-month-old baby a 2 years old clothes, right? So we have to understand after we learn the pattern, now we're gonna learning the model. So when we're learning the model, it's very important you know what are the requirements in order to using the model, right? Because the model has to fit with your pattern, right? So therefore, we are spend some time before we dive into the mathematical way. We're actually gonna look at, okay, what kind of requirement we need to impose on the data before we actually can use the model. Okay, as I said, moving average is the first model we are looking at. And both moving average and exponential smoothing, we call the smoothing method. So why they're important? As I mentioned at the very beginning of this module, that when we draw our time series line chart, and you're always gonna see up and down. So those random up and down is totally okay. We are fine, they existed, and nobody care about it. Since we don't care about it, how about we find a model that can smoothing those up and down out, only keep the core feature we are looking for, right? So therefore, this both method, moving average, exponential smoothing, we are trying to smoothing out those random fluctuations so that we are able to see we have the trend, we have any or horizontal pattern, any kind of pattern we can see. Okay, here I want to call out for the smoothing method. So both method we are learning here, you have to make sure your data has no upward trend or downward trend, no cyclical or seasonal effect. Okay, you might ask me, Dr. J, how about my data does have it? So actually in the next module, we are exploring some models that are able to help us to including some kind of trend and cyclical, okay? But if you're thinking about using moving average or exponential smoothing here, you have to make sure your data doesn't see any upward, downward trend, cyclical, and seasonal effect. And also, in my economic forecasting class, actually we are exploring other smoothing technique that actually allow you to incorporating some kind of seasonality in it. Okay, but here the two we are learning here are not cannot be applied to the time series that had a trend and the cyclical or seasonal effect. And so for the smoothing method, they are capable of adapting well to changing the level of the horizontal pattern. So it's perfectly fine for the horizontal pattern, but if you also see a shift of your horizontal pattern, it's totally fine too. And so for these two methods, it's easy to use and generally provide a high level of the accuracy for short range forecast. Keep in mind, so for these two methods, you cannot say, okay, I have weekly data. I'm going to use my weekly data to forecast the future 1 year. It doesn't work. So if you have the weekly data, maybe you forecast in the next 4 weeks. I think the model still works. But if you are thinking use these two methods to forecasting the next whole year, no, the accuracy will be way off. Okay. So keep in mind, the data has to be stationary. Again, no trend, no cyclical, no seasonality. And the second, you only can use these two models to forecasting a short range. Okay, short range. Okay, first let's look at moving average. So the moving average method uses the average of the most recent K data value in a time series as a forecast for the next period. So it's a little bit like what we just saw about using your historical average to calculating the forecast value. However, instead of what we see in the last video that we are, if you are in the week 1, week 2, you are using the last 1 week, week 3 using last 2 weeks. So you can see every time you're forecasting, you use different amount of the historical data, right? So that's not what we're talking about here. When we look at moving average, so we are using the same amount of the historical data to calculate the new data. So now you're going to ask, so how about I want to use in the past 3 period to forecast the 4th period forecasting result. So what you're going to happen is that you will skip the first 3 periods. So your forecasting will start on the 4th period, right? So therefore the K here in this formula is the number of period used to generate the forecast. Okay, so the numerator is, so this formula look a little bit complicated, but actually it's straightforward as we're going to look at example soon. So you basically look at your historical K period value and then calculate average. So that will be the predicted value for the following period's value. And then you shift the 1 more day and then to calculate using the same amount for historical period amount and then calculate average. So this method is called moving average. Okay, let's use an example to demonstrate how you actually can apply this formula to do the calculation. And also in our computer skill, I will show you how we can use Excel to calculate the moving average forecast. Okay, before we look at example, actually, there are a few things you need to consider. So the term moving is used because every time a new observation becomes available for the time series, it replaces the oldest observation in the equation and a new average is computed. So again, we're going to look at example. You will see that very straightforward. Here, I just want to call out about the choice of the K. So the K is how many historical value you want to use to calculate average, right? So value K is selected based on the number of the past value that are considered relevant. So the greater the number of the relevant past value, the larger the value selected for K. And some student might ask, how can I pick K? Try a few times. So that when I deal with a lot of real world problems, I do kind of try a few times to see what is the best the value for K. Okay, the rule of thumb you need to remember is that a smaller value of K will track shift in the time series more quickly. So think about our naive approach. So basically it is moving average, right? But since you only have 1 period, so therefore the average is itself, right? And the larger value of K are more effective to smoothing out the random fluctuation. So you kind of have to try a few K value when you deal with the real world problems to see which one give you a better forecasting result. So sometimes the smaller K works. It's really because the data had a horizontal trend, the fluctuation doesn't give you additional information. But sometimes the fluctuation do involving some kind of information you want to capture, so then you kind of want a little bit larger K. So for choosing K, definitely rely on experience, but for me, I also want to call out, try a few times, try a few different K value. That's going to give you the best answer on what is the best K for that time series data forecasting. Now, like I said, I want to demonstrating how we do the moving averaging using a case because the formulas kind of look complicated and also the explanation itself looks very awkward. Let's just look at a hands-on example, then you will be actually learn it very quickly. Okay. In my first column and the second column, first column is the time, second column is my actual time series data, and my third column is my forecast. So I'm demonstrating to you how did I get in this forecast. So my first forecast value is 19. How did I get it? So first of all, you can notice that my first 3 period forecasting are missing because the number of the forecasts are missing is the value for K. Okay, so K equals to 3 in this situation. And then in order to get in 19 is I first using this first 3 value, 17, 21, 19. I find the average value of these 3 value, I got 19. Okay, how did I get a 21? Again, we call it moving average. We are moving. So instead of using, I don't even know where. So instead of using all the past historical value, 1, 2, 3, 4 weeks, I keep my period the same. Okay, I only use 3 period ahead of my forecasting. So in week 5, so the 3 period prior week 5 will be week 2, 3, and 4. So I'm using 21, 19, and 23, and calculating the average, that's how I got 21. And then I shift again I shift to 19, 23, and 18, week 3 and 4 and 5, using that value to forecasting the week 6 value 20. Okay, so that is how those forecasting received. So after I receive the forecast result and I follow the last video, I will be able to calculating my measurement metrics that to measure the accuracy of my forecasting. Okay, so I can measure the MAE, MSE, and MAPE. So if you don't remember how did we get this result, make sure you watch the previous video. And then, so in each case, the 3-week moving average approach provides a more accurate forecast than the simple use in the most recent observation as forecast. So as you can see, MAE is 2.67, MSE is 10.22, MAPE is 14.36%. If you look at our naive forecasting we did before, it is better than naive, right? Is that better than the average as well? So average is 2.44. You look at this, 2.44 on. So it seems like this one is a little bit performed less well than the average of the historical values. Okay, but this method is called a moving average forecast. And we can see it's significantly improved compared with the naive. But for this data set, it's not doing as better as the using the historical average of all the historical price. Okay,